When people imagine alien life, they usually picture something distant and unfamiliar, a strange biology evolving under a different sky, on a planet far from Earth. It feels safely remote, but the most radical possibility may not be light years away at all. It may already be here, embedded in the devices we build and use every day. To see why this idea isn't as strange as it sounds, it helps to start with a small detail from chemistry. Silicon sits directly below carbon on the periodic table. That placement isn't arbitrary. Both elements have 4 valence electrons, which means both can form 4 chemical bonds. Because of that, scientists have seriously discussed silicon-based life for decades, not as science fiction, but as a theoretical possibility. Carbon-based life works because carbon forms stable, flexible chains. Those chains can store information, build complex structures, and support an enormous range of chemical reactions. That flexibility is why every form of life we know is carbon-based. Carbon chemistry is uniquely good at producing complexity that can change, adapt, and persist. Silicon looks similar on paper, but it behaves very differently in practice. Silicon-silicon bonds are weaker, and silicon strongly prefers to bind with oxygen. The result is silicon dioxide, a rigid solid rather than a gas like carbon dioxide. In water-rich environments like Earth, this chemistry is a dead end for metabolism and evolution. It locks matter into structures that don't easily rearrange or adapt. That's why no silicon-based life has ever been observed. No experiment has shown silicon chemistry capable of self-replication or open-ended evolution. In mainstream astrobiology, silicon life is usually described as theoretically possible but extremely unlikely. And yet, silicon has quietly become central to something else. Modern machines are built on silicon, not in a biochemical sense, but in a structural one. Silicon semiconductors store information, process signals, and manage energy flows at enormous scales. Software running on those systems encodes memory, behavior, and decision-making. Increasingly, that behavior can change over time through learning and adaptation. By any current biological definition, machines are not alive. They don't maintain themselves without human support. They don't reproduce on their own. They don't evolve independently in open-ended ways. Calling them silicon-based life today would be wrong. But that conclusion rests on a deeper question we rarely examine. What do we actually mean by life? Biology doesn't define life by its material alone. Life is usually described in terms of what it does. It stores information, maintains itself against entropy, adapts to its environment, reproduces directly or indirectly, and evolves over time. Carbon-based organisms meet these criteria through organic chemistry, but nothing in physics says those functions must be implemented using carbon. They are functional properties, not chemical obligations. Now imagine a future system that can maintain itself, build or manufacture successors, adapt without human intervention, and evolve across generations. If such a system existed, rejecting it as not alive would be a philosophical stance, not a scientific one. That's where this idea becomes historically significant. If machines ever cross that threshold, humanity's first encounter with non-carbon life will not come from another star system. It will happen here, on Earth, in systems we designed and assembled ourselves. Not silicon-based life in the biochemical sense, but silicon-based in structure, function, and information processing. Our first alien may not arrive in a spacecraft. It may power on. This doesn't mean machines are conscious. It doesn't mean silicon chips are cells. And it doesn't mean biology becomes irrelevant. It means something narrower and more unsettling. Silicon-based life in chemistry remains hypothetical. Silicon-based life in technology is approaching a boundary where our definitions begin to blur. And before we discover life in the universe that isn't carbon-based, we may have to decide whether we're willing to recognize it in the systems we create ourselves. Because the most unfamiliar form of life we ever encounter may not come from out there. It may be something we built, simply by taking silicon seriously in a very different way.